Okay. So this is question number 17. It's a word problem. The bottom of a river makes a V shape that can be modeled with an absolute value function. Here's the function given here. Where D is the depth of the river bottom, remember that. D is depth of the river bottom, and H is the horizontal distance to the left-hand shore. Remember that. A ship risks running aground if the bottom of its keel reaches down to the river bottom. Suppose you are the harbor master and you want to place buoys where the river bottom is 30 feet below the surface. How far from the left-hand shore would you place the buoys? Okay, so we have a word problem. The questions that we should ask ourselves is first, what information is given? And second, what are they asking for? All right, so what information is given to you here? Here's two specific pieces of information that I'm interested in. Anybody? The formula. There you go. That's one. So here's the formula. That's a nice piece of information that will probably be helpful. Okay. What's the next piece of information? Yes, Ms. Escobar. 30 feet below the surface, right? Good. So, okay, so we have two pieces of information. We have the formula and the fact that we have 30 feet below the surface. Okay, so what is 30 feet below the surface? We have two things here. We obviously are doing math, so we're not just going to use words. We're probably going to use letters or numbers, variables, right? Something like that. So we probably want to set something equal to 30, or it's 30 below the surface, right? So it's probably negative 30. So what's equal to negative 30? What's equal to negative 30 here? We have only two variables. What are our variables? D and H. So is H equal to negative 30? D, the depth of the river bottom. Oh, it's 30 feet below the surface, so we know that D equals negative 30. So that's our second piece of information. We have our formula, and we have that D is equal to negative 30. So what is it asking me to solve for? Now it's what is it asking for? That's the second question. So we figured out the information given, then what is it asking for? Who can tell me? Someone raise your hand. You can usually tell what a question is asking for because there's a question mark. So which sentence has a question mark? How far from the left-hand shore should you place the buoys? Okay, we've already got that one of our variables, D, is equal to negative 30. Which variable is it asking us to solve for? H, yes. How far from the left-hand shore? Okay, H is the horizontal distance to the left-hand shore. There you go. So it's asking us to solve for H. So it gives us D, it's asking us to solve for H. What should we use to solve for H when given D? We only have two pieces of information, one of which is what D is equal to, and the other piece of information is what? The formula. So what can we use to solve for H if we're given D? The formula. Yes. Okay. Hurricane Irma. All right. Negative 30 equals, set D, we plug in D, negative 30, into this formula. D is negative 30 equals 1/5 H minus 240 minus 48. Okay, now we have what? An absolute value equation, right? We have an absolute value equation. Can we solve an absolute value equation? Yeah. That's the whole thing that we were doing in this homework, which you may or may not remember at this point. Okay? Add 48. The first thing, remember, it's IRS. Isolate. Rewrite and solve. Isolate, rewrite, and solve. So we isolate. We add 48 to both sides. This ends up being 48 minus 30 is 18 equals 1/5 times H minus 240. What's the next step, class, if I'm isolating the absolute value? Not divide by 5, but multiply by 5 over 1, or just multiply by 5. That cancels that out. Close, though. And we end up with 5 times 18 is, anyone? 5 times 10. What's 5 times 10? It's 90 in total, yeah. 5 times 10 is 50. 5 times 8 is 40. 50 plus 40 is 90. Equals the absolute value of h minus 240. But have I isolated? Yeah. All I've got left is my absolute value. So now I rewrite. Okay, so I rewrite it as h minus 240 equals 90. And h minus 240 equals what, class? Negative 90. Good. Add 240 to both sides. And I've got h equals 330 and h equals 150. Okay, so it gave me the depth, negative 30, and I've solved for my h, 150 and 330. So if I look and I find 150, that's right here. There's my depth, and 330, that's my depth right here. Well, if you take a look at both of these points, yeah, the depth is negative 30, right? The depth is 30 feet below the surface. You see? Okay, so all this was, class, this might seem super confusing because it's a word problem, but basically all it was it gave you a function, it gave you a value for d. Once you plugged in that value for d, you're solving an absolute value equation just like we've done before. Does that make sense? You guys understand that? Okay, any questions there? Okay, so it's just a little bit more involved than a regular one. Okay, so just so you guys can be refreshed, 2 times the absolute value of x minus 4 plus 1 equals 5. Okay, how do I solve this? I do the IRS, which is isolate, rewrite, and solve. Okay, so what's the first step to isolating this absolute value equation? Brendan? Subtract 1 from both sides. There you go. 2 times the absolute value of x minus 4 equals 4. What's the next step? Raise your hand, someone, please. Divide by 2. Go ahead. Divide by 2. Okay, now I've got absolute value of x minus 4 equals 4 divided by 2 is 2. Have I isolated absolute value, class? Yes. So now I, class, rewrite. X minus 4 equals 2, and x minus 4 equals negative 2. Add 4 to both sides. And I end up with x equals 6 and x equals 2. And if I plug either of those into the equation, I should be able to see that I got the right answer. You see, isolate, rewrite, solve. That last step here is, once I rewrote it, I just solved for x. You see? You guys remember that? Any questions? Okay. Let's move forward. Section 2.3. Solving absolute value inequalities. All right. We started by graphing absolute value functions. Then we, in section 2.2, solved absolute value equations. Now in section 2.3, we are solving absolute value inequalities. Okay, what's the difference between an equation and an inequality? Who can tell me? Ask Uranus. Go ahead and give your best shot.
What was the question?
What's the difference between an equation and an inequality?
Equation has an equal sign.
Yep.
Inequality is not equal.
Essentially, it is equal, but it has what? Not an equal sign, but an inequality. Yeah, right? Less than or greater than, right? Makes sense? Okay, cool. That's what an inequality is. It's a less than or greater than, more than, less than, whatever you want to call it. Okay, the gators, whatever you want to call it. Okay, so we are now solving absolute value inequalities, which have this inequality in there. It's either less than or greater than. Okay, so let's take a look at this. First, we're going to visualize it. We have this function here. Okay? We have this function here. X, absolute value of x plus 2 is less than 5. Rather, we have this inequality here. Okay? We're now asked to figure out whether or not these numbers are solutions to this inequality. So what we're going to do here in this table is plug in the numbers and see if they are solutions. So let's go ahead and plug in -5. What's the absolute value of -5? 5 plus 2 is 7. Is 7 less than 5? Is 7 less than 5? No. So it's not a solution. Okay? Plug in -4. Absolute value of -4 is 4. 4 plus 2 is 6. Is 6 less than 5? No. Plug in -3. Absolute value of -3 is 3. 3 plus 2 is 5. Is 5 less than 5? No, it's not. It's equal, but it's not less than. Plug in -2. Absolute value of -2 is 2. 2 plus 2 is 4. Is 4 less than 5? Yes. And then we plug these all in. -1 is 1. Plus 2 is 3. 3 is less than 5. 0 plus 2 is less than 5. 1 plus 2 is less than 5. 2 plus 2 is less than 5. Then we get over here to 3. 3 plus 2 is 5. We know that 5 is not less than 5, so that's a no. And then so on and so forth for the rest of them. And then it asks us to plot our solution. Okay? Now, if this was only integers, then the only solutions would be -2, -1, 0, 1, and 2. If they were only asking us for the integers that were solutions. But what if it was all real numbers? Okay, if it's all real numbers, then that includes decimals as well. So let me ask you something. Would 2.9 be a part of this solution? What's 2.9 plus 2? 4.9. Is 4.9 less than 5? Yeah. What about 2.999? Would that be part of the solution? Yeah. What about 2.99999? Would that be part of the solution? Yeah. So everything up to 3, but not including 3, is part of a solution. So 3 is excluded. How do I show that on my number line? What do I do if something is excluded on this number line? What do I do? Do I put a closed point? No, an open point. And what about -3? Should I put a closed point there? No, I should put in open point. You guys get the idea? So this is my solution. Okay, not just these specific integers, but all the points up to -3 and +3, but excluding those. Okay, and if we were to write this as an inequality, we would probably write it, or we would write it something like this. Does that make sense to you? Does anyone have any questions of why I did an open point here at -3 and +3? Any questions there? No? Okay, and so we've seen this inequality notation before. That was our first module. Module 1, we learned inequality notation. Okay? So x is less than 3 and greater than -3. Okay? So we write it in this format. But now let's go on to the next one. Absolute value of x plus 2 is greater than 5. We plug in -5. Absolute value of -5 is 5. 5 plus 2 is 7. Is 7 greater than 5, class? I imagine more than one person knows that 7 is greater than 5. Let's pick it up. We can do this. All right, an absolute value of -4 is 4. 4 plus 2 is 6. Is 6 greater than 5, class? Yes, it is greater than 5, indeed. Okay. Plug in -3. -3, absolute value of -3 is 3. 3 plus 2 is 5. Is 5 greater than 5, class? No, it is not. Okay, and then plug in -2 is 2, plus 2 is 4. 4 is not greater than 5. Same all throughout here. No, 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 no. Until we get to 3. 3 plus 2 is 5. 5 is not greater than 5. So until we get here to 4, 4 plus 2 is 6, which is greater than 5. 5 plus 2 is 7, which is greater than 5. So in this case, the only ones that we would plot would be negative 5 and negative 4, positive 4 and positive 5. So if it were just integers, that would be our answers. Those would be our answers right there. But if it was all real numbers, well, let's see, would 3.1 be part of the solution? 3.1 plus 2 is 5.1. Is 5.1 greater than 5? Yeah. So 3 isn't included, but everything up to 3 is included. So we do an open point there and at negative 3. And then all of our answers are in this domain. Okay, so now, here's the thing, right? We wouldn't say x is greater than 3 and x is less than negative 3. And the question is why? Someone give me a number that's greater than 3 and less than negative 3. Greater than 3 and less than negative 3. I hope your minds have hit a brick wall because it's impossible. You can't have a number that's greater than 3 and less than negative 3. So you wouldn't say and, you would say or. You would say x is less than negative 3 or x is greater than positive 3. Okay? X is less than negative 3 or x is greater than positive 3. So it's or. And so the only question here is, how do I know which is which? Okay? You see, this is different. This is written like this, and this is written like this with an or. Okay? And the way that we figure this out is by the way that the inequality points. Okay? If it's less than, you see that this is a less than sign? Class, what is this sign right here? What is that showing us? It's less than. You see? It's less than. Then it is written like this. Okay? This is the format. And here. If it's more than, then it's written with an or. You see? And you see how this is on the outside? So it's less than, it's on the inside, it's and. If it's more than, it's on the outside, it's or. So less than, and, more than, or. You see? That makes sense? Less than, and, more than, or. Okay? Now, let's go ahead and solve this algebraically. You guys see the deal here? These are all the solutions of this inequality. Okay? But we solved them in kind of a roundabout way, so now let's solve it algebraically, and I think this should make your lives a little bit easier. So if I have absolute value of x plus 2 is less than 5. That's the first one, okay? This isn't in your book. Your book doesn't do this. Okay? I want to now solve it algebraically. I do the same process. First I isolate, I rewrite, and then I solve. So first I isolate by subtracting 2 from both sides. And I get absolute value of x is less than 3. Okay? Once I've isolated, isolate, now I rewrite, but listen, it's less than, so remember, less than and, more than or, so I write it like this. The notation is like this. And I rewrite it, this is how I rewrite. First, I just drop the absolute value, then I bring this over, and I make this negative. Okay? That's my notation, if it's less than. And I'm done. I don't have to solve because there's nothing left to do. Can you guys see that? You understand that? Now, the other one was absolute value of x plus 2 is more than 5, greater than or more than 5. So first I isolate by subtracting 2 from both sides. I get absolute value of x is more than 3. So I've isolated. Now I rewrite, and I rewrite by dropping the absolute value. That's always the first step, is I drop the absolute value. But this one is more than, so I don't write it with this notation, I write it as or. It's more than, so it's or. So it's x is greater than 3, or x is less than -3. You guys understand that? Can you see that? Okay, you guys are being very quiet, which is always dangerous. Let's do another one. Absolute value of x, almost the exact same format, plus 1 is less than 4. Okay, go ahead and do that one. It's almost the exact same question. Go ahead and do it to make sure you know it. Do it on your scrap paper, wherever you want to do it. It's fine. Make sure you are writing right now. I'm telling you, if the first time you solve a question like this is on the test or on your homework, it's not going to be easy. Okay. First I isolate. What's my first step? Miss Hill. Yes. Subtract 1 from both sides. So I've isolated. Now I rewrite. Is this less than or more than, class? Less than. So it's and. So I rewrite it like this. First I drop the absolute value, but it's less than, so I bring this inequality to the other side, and I make this number negative. You see? That's because it's less than. You understand? You guys get that? Okay. Now let's do another one. Almost the exact same. Absolute value of x plus 1 is more than 4. Go ahead and do this one on your own. That was less than, so it's and. This is more than, so it should be or. Okay, so let's solve it. We isolate first, subtract 1 from both sides. We get the absolute value of x is greater than 3. I've isolated, so now I rewrite. First step is just drop the absolute value. It's more than, so it's or x is, and then I flip everything, less than, and then make that negative. See? See how I do that? Is that pretty clear? Okay. You have to follow the pattern based on the direction of the inequality. If it's less than, you write it with this format. If it's more than, you write it with this format. Less than and more than or. See? Okay. Any questions on that? Okay. Now, let's go ahead and do one from your homework, which is a little bit different. So let's do number 12 on page 79. So here you can tell it's a little bit more involved. So let's go ahead and do this one. I'm going to rewrite it here. Absolute value of 2x plus 1 minus 4 is less than 5. Remember, our steps here are isolate, rewrite, solve. Okay, so our first step is to isolate. So what's my first step to isolate this? How do I isolate it? Add 4. Good. Add 4 to both sides. End up with the absolute value of 2x plus 1 is less than 9. Have I isolated, class? Yeah, all I have on the left-hand side is my absolute value. So I'm going to rewrite it. It's less than, so it should be what? And or? And. Less than and. 2x plus 1 is less than 9. Drop the absolute value. That's the first step. Then I bring this inequality over, and I make this number negative. And that's the rewrite step. Okay? Now, once I've rewritten, I have to solve. Now, this case, I actually do have to solve. Usually, in the previous 4 questions, it was all just x. But there's not just x here, so I have to solve. So how should I solve this? What's the first step to do? Subtract 1. But do I just subtract 1 and then call it a day? Maybe from here and then call it a day? No, I got to do it from every single side. Okay, so it's negative 10 is less than 2x is less than 8. Next step, divide by 2. Okay, this is then negative 5 is less than x is less than 4. Then it asks us to graph it. So we can go ahead and do that. It's less than, so we know it's exclusive. X is greater than negative 5 and less than 4. And that's our solution set right there. Does that make sense to you guys? Is that pretty clear? Yeah? Any questions on that? You guys kind of getting that?
Yeah.
You getting the deal? Less than and more than or? You see the 2 different formats? Okay. Anyone need this up still? Okay. All right, see, those math brains are starting to crank. I like it. I like it a lot. Good job. All right, let's do another one. Number 13. Okay, so I'm going to rewrite it. We get 3 times the absolute value of x plus 4 plus 2 is greater than or equal to 5. Remember, our steps are isolate, rewrite, solve. What's the first step in isolating this one? Subtract 2. Good, good. Subtract 2 from both sides. So we end up with 3 times the absolute value of x plus 4 is greater than or equal to 3. Have I fully isolated it yet, class? No. Brendan, what do I do? No, just this. There's only 2 sides here. Okay. What do I do? Who can tell me? Mr. Evans. Good job. Yes. Divide by 3. All right, absolute value of x plus 4 is greater than or equal to 3 divided by 3 is just 1. Okay, have I isolated the absolute value now, class?
Yes.
Yes. Okay, so I've isolated, so now I rewrite. It's more than, so it's or. X plus 4 is greater than 1, or, so first I drop the absolute value, or x plus 4, flip this inequality so it's less than or equal to, and then make this negative. Negative 1. I've rewritten now. You see? And that's because it was less than, or is more than or equal to, or greater than or equal to. More than, so it's or. Now I've rewritten, so my next step, my final step here is solve. So if I've written it out correctly, it should be clear that I've got to subtract 4 from all these. And it's x is greater than or equal to -3, or x is less than or equal to -1 minus 4 is -5. And it asks me to graph it, so I will. X is greater than or equal to -3, so it's inclusive. Greater than or equal to -3, so that's all these things here. Or less than or equal to -5, so that's all these things here, all these ones. All these numbers. You see, class? You get the idea? You get the idea here? We have now learned how to solve absolute value inequalities. Sweet. Hey, first day back in math class, already gaining new tools in the toolbox. I like it. All right, any questions? Okay, there's 2 things that I've left out here, and let me show you. Does anyone need this up still? No? Okay, look. What if I say the absolute value of x is less than a negative number, less than -3? No solutions. Why not? Yeah, you can't make it negative. No matter what I plug in here for x, it can't be negative. And it definitely can't be less than a negative number. It doesn't make any sense, right? There's no number that I can plug in that will give me an answer, so it's no solutions. Got it? Okay. What about absolute value of x is greater than a negative number? What was that? There are solutions, but what are the solutions? Bam. There's nothing I can plug in there that would end up being less than -3 or even equal to -3. So the answer is all real numbers, which you can symbolize by that, which means all real numbers. Does that make sense to everybody? Every number I plug in, -1, 0, 50, 1,000, everything will be greater than -3. It doesn't matter. Okay, so the answer is all real numbers there for the solution. Does that make sense? So if it's ever less than a negative number, it's no solutions. If it's ever greater than a negative number, it's all real numbers. Does that make sense? Okay, now the thing is, you have to be careful here because that's only true once I've isolated it. All right, for instance, if I give you, and this is the last thing, -2 times the absolute value of x is greater than -4. You might say, oh, it's greater than a negative, so it's all real numbers, right? Well, you have to isolate first. So to isolate, I'd have to divide by -2. And who can tell me what happens when I divide across an inequality by a negative number? Divide or multiply? It flips, right? So its absolute value of x is less than -4 divided by -2 is +2. Okay? So then you would have to go ahead and solve. So it's not so simple as just saying, oh, it's more than a negative, so it's all real numbers. No, you have to isolate first. Got it? Okay. Any questions? Good. Now, check it out. Schedule. All right? On tomorrow, we have our test review. On Thursday, we're going to have our test. Our test is going to be on mostly unit or module 2, but also we'll have some things included from module 1, most likely things like domain and range, and also inequality notation. Obviously, we have to know inequality notation, so that's right there in there. You understand? So, but we're going to do a review tomorrow, and our test is on Thursday. When's our test, class? Thursday. You guys have homework tonight. You don't have to watch any videos, but I recommend that you go ahead and do your review before our test review tomorrow so you can have questions for me. Because obviously on the day of the test, you're not going to be asking any questions. Okay, so go ahead, start studying. Your test is on modules 1 and 2. Okay, so that's lesson 1.1, 1.2, 1.3, 2.1, 2.2, 2.3. You have homework, it's 2.3. Homework on lesson 2.3, it's numbers 1, 2, and 11 through 19. Okay, so we're skipping 3 through 10. Okay, any questions on that?
Yes.
No. Yes. You can go.
You didn't go over how to graph it.
Yeah, we're not doing that.
Okay.
We're not doing that. We're skipping that. Okay? All right, good job, class. Yep.
Where are you going?
Skipping it. Okay. Good.